What's up?
I thought you had that live. Yeah, like that one of my break
Live?
Yeah, I could catch it.
No. Grossmont's Wi-Fi is not good enough for that kind of stuff. Come on. And I ain't gonna use my data for that kind of stuff. All right, guys, we got a lot to do. Any questions on that quiz before I pass it by? Yes, sir. Anybody need a copy of the practice test? You didn't get it yesterday. Everybody else got a copy of the practice test, right?
Yeah, I'll take one too.
You'll take one? Oh, okay. Practice test. Get practice test, yeah. All right. So any questions on the quiz? You guys are good with the quiz? Okay. Very quickly, I didn't put it down on there. The average was just under an 80. 13 A's, 5 B's, 2 C's, 2 D's, and then 7 F's. Okay. So if there's no questions from the quiz, we're going to get right back into what happened? You right?
We had a mini meltdown back there.
What?
We had a mini meltdown back there.
Oh, well, shit. As long as it's contained and over. All right. We had one thing left to do in 10.4, but let's do a little review real quick of what we've done so far. Okay. So rewrite this in exponential form. Let's see if you guys understand that instruction. If I had cube root of x squared, how do I write that in exponential form? Yep.
Yeah, that's it.
X to the 2 over 3. You gotta love the way to remember this, right? Roots, bottom of plants, the root goes on the bottom. Power's gotta go on the top. Okay? So what if I had 4th root of x cubed y squared? X to the 3 over 4? Y to the
1/2.
2 over 4, which is 1/2. I like it. So 2 over 4 reduces to 1/2. Okay. What about the other way around? Rewrite as a root. Rewrite as root. A to the 7/11ths. Careful. 11th root of a to the 7th. Or the 11th root of a to the 7th. I just want to make sure you guys are really cool with what I just did, because this is huge. If I put a number here, you want to do it this freaking way. And we'll do an example right here in a second. Why are both of these the same? I don't know, because you people said so. No.
The exponent? The A?
Yeah, watch this. A to the 7/11ths. Isn't that A to the 7 to the 1/11ths? Isn't that the same thing?
Yeah.
And that's what this says. That's the 11th root of A to the 7th. Isn't it also A to the 1/11th to the 7th power? Doesn't really matter what order this is in, because I'm going to multiply them, right? Aren't these the same then? They're both A to the 7 over 11. Isn't that one this? 7th power on the 11th root. That's that one. As long as 7 is a power, it doesn't matter if it's on the inside or on the outside. If it's a variable, we normally write it like this. That's the most compact form. If it's a number, I do not want to write this shit like this. Let me show you. If I had What, Jeff? I don't know, man. You could do it 27 to the 4/3 power. You could write that as, what's the root going to be?
3.
Cube root of 27. You could do this. Do you really want to multiply 27 by itself 4 times?
No.
And then try to figure out the cube root of that? No, I don't want to. Screw that. I want to do cube root of 27 because I know what the shit that is. And then what do I need on the outside? 4th power. I need the cube root and a 4th power. What's the cube root of 27? 3. And what's 3 to the 4th power? 3 times 3 times 3 times 3. 9 times 9.
81.
81. You guys see that? You can choose where the power goes. So of course for numbers, you're going to choose that power to go on the outside, because then I can do the root part, make it small. I don't want to do 27 to the 4th power, do you? No? Yeah, okay.
Only on the calculator.
Yeah, exactly. How are we doing? Yes.
So you got, how do you get 3 to the 4th?
Who?
How did you get to that point with the 3 to the 4th?
Well, are you cool from here to here?
Yes.
What is the cube root of 27? 3, right? What does it take 3 of to multiply with 27?
Okay.
3.
And then the exponent or whatever, you just place it down there?
Say again?
The 4 is the exponent.
It's exponent. He's
Yeah.
asking for the 4 is the exponent.
Yeah, 4 is the exponent. It's okay. Right? Okay. So I rewrote what cube root of 27 is, and whatever that is, I have to raise it to the 4th power.
And you just X the one on the bottom up just to show us that.
Yeah, that's another way I could have written it, but I don't want to work that out.
Yeah, it's easier to write it.
That's the better way to write it, because then it's easier to work out.
Okay.
Okay, I like it. Okay. All right, all right. And then the more recent stuff we've done, like, how about,
Factoring of the damn square.
who's a what? What is it? Who?
The factoring of the square root.
Oh, that's just one little thing. Like this here.
Root a to the 5th.
Yep. Since they have the same root, I'm allowed to multiply the insides. 4th root of a to the 5th. Now what can I do with this? 4th root needs how many things inside? 4. I have 5 things inside. I should be able to do something then.
Oh, you can take the A4.
4 goes into 5
One.
once with
One left.
1 left over. Watch this.
Oh, okay.
What is this? A to the
4, 5 on 4.
5/4. What is 5/4? 1 and 1/4.
Uh-huh.
I have a whole A, bam, and a 1/4 of an A, bam.
Oh.
No? Yes?
Okay.
The idea is what's important. Do you understand the idea? Yes.
The indexes were different.
Then you couldn't do what I did, but so here's another one. Is everybody cool with this? You don't have to do it this way, but this is actually kind of a cool idea because that shows you the whole part and the radical part. The whole thing and the radical thing.
Gotcha.
Okay, now, what if I had the same kind of problem, 4th root of a squared, but this one was the 5th root of a cubed? I can't do what I just did, but I can do something.
Oh.
Why? Because the bases are the same. Let me write it in better format. What's the better format for this?
A to the 4th?
A to the 2/4, which is 1/2. Is that cool? No? All right, redo it. That's A to the 2/4. Isn't 2/4 freaking 1/2? Okay. Times A to the
3/5?
3/5. What do you do with the powers in this case?
Make them the same.
LCD, because you got to add them. So why am I able to do something here? Because the roots were the same. Why am I able to do something here? Because the bases are the same. One of those two things has to be true for you to be able to do something.
If they're not, then it's,
If it's not, then you just circle. Say, I'm done.
oh,
Yeah. So here it would be 5/10, 6/10, 11/10. You can write that in root form if you really feel like it.
You only ask us to write it in root form if you want it like that?
Yep. If I said write this in root form, what would it be?
A 10.
Who? What?
10th root
10th root.
with A what? What's the A?
A on the outside.
Oh, A what?
11.
Oh.
11.
11.
5/10 plus 6/10 is 11/10. So this would be A11, which is 10 goes into 11
One time.
one time with
That's what I was-
one left over. Don't jump over a step for me. Okay. So radicals. Roots are fractional powers, which just makes every bit of sense. Because roots cut things down multiplicatively, and that's, so there you go. It should be a fractional power. It should cut things down multiplicatively. Perfect. Right? And then all the old properties of powers are the same. Okay. And then finally we have something more direct, like, what's the square root of x to the fourth?
X times X times X times.
That's what x to the fourth is. But what's the square root of x to the fourth?
X.
Yeah, because what's the square root do cuts thing in half. So don't make a big deal out of it. This would be x squared. Now do I have to have absolute values?
Yes.
Normally, yes, but x squared cannot be
Negative.
negative, so I don't need it. If you put it, I'm not going to take points on. What is the cube root of x to the ninth? X to the third. Do I need absolute values there?
No.
If you put them, it's wrong. Because what should be true about an odd root, the answer has to be allowed to be negative sometimes, right? So I can't put an absolute value unless it's wrong. Yes?
So question about the one before, when you leave it to 10 to square root of a 10 to the square root of a, so is the goal to only leave one a in there?
No.
Or
No.
what's-
Nope. All right, two things. If this is a times the 10th root of a. There's no square root here. Okay.
Yeah.
If it was the 10th root of a to the 15th, or let's say 17th, yeah.
Yeah.
10 goes in 17 once,
Mhm.
with how many left? 7.
Oh, gotcha.
There's no goal there. It's just do as much as you can, leave the shit you can't. Here, there just happened to be one piece of shit I couldn't. This would have to be 1A that was extra, right? You little piece of shit.
Wait,
Yeah.
question. Would you accept that answer, the one that you circled in the test? Or
Yes, totally. If I don't say how to leave the answer, I don't know if you picked it up on with me or not yet that I prefer this form. I don't like the root form, to be honest. But you have to be able to work with both because they're both out there. Right? I can work with both. I just like that way better. But if I don't say it, doesn't matter. If you want to take it to root form, I'm not going to hold that against you.
So the one that isn't circled is root form, and what is that one?
Okay, so the root form must be the form that has a root in it.
Okay.
So that's root form because it's got a root symbol, right? 10th root. This is exponential form because it's got an exponent. Yeah. Lock it. Okay. For the most part, catches us up to everything. I think, yeah. Okay. And erase this. I'm going to do one division kind of problem to show you that because I don't think we've done a lot of those. And then we got to talk about rationalizing denominators.
What chapter are we going up to for the test? 10.6? 10.5?
Haha. Listen to you. Hopeful person. 10.6.
10.6?
Yeah.
Okay.
Yeah. So 10.7 and 10.8 will be on the next test.
Just had to clear out what homework assignment we had to finish.
No, I understand. It's all good. So this is still 10 4. Here we go. So a division problem, let's do a division problem real quick. So if I have the cube root of 16a5 b squared divided by the cube root 2a squared b 6, no, b 8. I feel so bad for the people that work on the top and they work on the bottom. Oh my God, that is disgusting. It'll work. But what are you allowed to do?
Kill roots.
You definitely can't kill the roots. They're a good band. The only way I could kill these is if I cube the top and the bottom, and you ain't allowed to do that to a fraction, right? If I had 1 over 2, what's 1 cubed? Is 1 over 2 equal to 1 cubed over 2 cubed? Is 1/2 equal to 1/8? No, you're only allowed to multiply and divide with something, right? So I can't kill those roots, but the roots are the same. So what am I allowed to do then?
Kill the others.
I'm allowed to reduce the other stuff, right? These 2 cube roots can become one big ass cube root, basically is the idea. Right, it's like little soap bubbles kind of merging together. What am I taking the cube root of? Everything. Okay, here's the cube root of everything. And now I can simplify the inside, thank God. What's 16 divided by 2? 8. What's a5 over a squared? 8 to the third. And what about b squared over b8? How many b's are left? 6. Where? On the bottom. I avoid negative exponents if I can, because it's a negative. It's a place I can make a mistake. Does that make sense? Don't 2 b's cancel? 6 are left. On the bottom, of course, because that's where more of them were in the beginning. Right?
So if the roots weren't the same, you couldn't do that.
You couldn't do what we're doing.
Okay.
Yeah.
Could you do?
You could simplify the top and the bottom separately and see what happens. Yeah.
Okay.
Right? Because you could do cube root of 8 is 2, and it leaves a 2 inside. 3 goes into 5. Do you see what I'm saying?
Yeah,
You
yeah.
do that kind of weird shit. Just don't do it if the roots are the same. Dear God, reduce the shit you're looking at.
Yeah.
And now what's this? What's the cube root of 8?
2a.
2.
2.
Cube root of 8 cubed. A cube root of b6.
B2.
B squared. I like over here, over there. Ask Mark what math will do for you. Okay, so that kind of catches us up to this rationalizing the denominator. This is still 10.4. Okay. So, do you agree that radicals normally lead to gross-looking numbers if you try to do them, right? These decimals that never end. Most radicals are irrational numbers. You guys cool with that? Square root of 2 is 1.414, blah, 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 blah. It never stops. There's no pattern to it. That's kind of gross, right? You guys with me? Some of you guys are Googling stuff. I don't know if it's related to what I'm saying. So what would be even worse is if that sucker was on the bottom of a fraction. Now I'm dividing by grossness. Okay. So now watch. So if I have this 1 over the cube root of 3. So here's what the phrase, is everybody cool with that? That's just what I have. That's the problem. That's the problem that they would give me, and they would say, rationalize the denominator. So what I just say, most roots are irrational. So rationalize the denominator means make the bottom so that it comes out to be a whole number, not irrational. So that's what rationalize means. Make it a rational number. Right? What about the top? Well, the top can become whatever the shit it becomes. So why can I not do the cube root of 3? That's a very strange question, but see if you guys can piece it together. Why can't I do the cube root of 3 and have it come out nice? Why can I do the cube root of 8? Why? Why can I do that one?
Breaks down evenly.
Huh?
It breaks down evenly.
Breaks down into how many parts?
1, 2, 3.
3, because it's a cube root, right? 8 is 2 times 2 times 2. Are you with me? That's why I can do the cube root of 8. Why can't I do the cube root of 3? Because 3 is just 3. There's just one 3 in there. Do you want to break 3 into 3 parts? No, don't say 1, 1, 1. I'm talking about multiplicatively. Oh my God. What multiplies to be 3 if I do it times itself 3 times? I don't know. All right, now, how many more 3s does this poor dude need?
2 more.
2 more. So I could give it to him. I could give him what he's missing as long as I do the same thing to the top. I mean, so I don't call this rationalize the denominator. I just call it complete the root. What's the root need? 3 things. What's in there? 1 thing. Let me give it 2 more. If there was a 5th root, I'd give it how many more 3s? 4 more 3s. So what I'm going to multiply by, I can't just multiply by 3 squared. Why can't I? Can I put these together? There's 2 more 3s, but will it ever be able to get in there? No, because it needs the same root. So I'm going to multiply by the cube root of 3 squared. I really want you guys to see why this makes total sense. Why does it make sense? Because like we said, if I give this guy 2 more 3s inside, I'll be able to do the bottom. It's going to be a nice number, right? So what's the top become? Cube root of 9. Too bad for him. What's the bottom become? Cube root of 3 to the 3rd. I love it. I was hoping somebody would say that. Cube root of 27 too, but either way you look at it, what's the answer for the bottom? 3. Is the bottom rational now? Yes. A rational number means something that could be written as a fraction. 3 is 3 over 1. There you go.
I don't get from step 1. You gave the bottom 2.
2 more 3s.
Right.
Does it make sense why I did that?
Yes, because you want it to be able to be a 3rd root.
I love it. Okay.
But why did you give the top a root of 3 as well instead of just 2 more 3s? You get what I mean?
I don't understand.
You matched it exactly instead of just giving it what you...
Why do these have to be the same? Because whatever I do to the bottom of a fraction, I have to do the same damn thing to the top, or else it's illegal.
It's like dividing by 1.
No,
Yes,
I
like
get-
multiplying by 1.
I just don't... So you're giving it 2 more 3s, but you also gave it a square root. The bot, like you-
Oh, like I said, if I didn't give it a root, how could those 2 3s get in there? Can you multiply those together? No, because they don't have the same root. What's the only time you're allowed to multiply things together if they have the same root? Can I ever get those 2 3s in there? No, they don't have the same root. What's the cube root of 3 times 3 squared? 9 times the cube root of 3. I can't do shit with that. But if I make it the same root, now those 2 3s can go inside. They have the same root. This is the cube root of 3 times the cube root of 3 squared is the cube root of 3 cubed, which simplifies beautifully. Does that make sense? I have to multiply by the same root so that they're able to go together. I want to give this guy 2 more 3s. The only way in is to wear the same shit he is. So I'm going to wear the little cube root so I can get in there. Let me in. I got the cloak. Okay. Whatever. Soul Society needs. San Diego Druids. We can go inside. All right. It's mostly just for me, I guess. So let's try another one. What about 5th root of y over the 5th root of 8m4? I like it. Why is it silly to say that the bottom is missing 4/8? Some of you guys are like, that's exactly what I was thinking. Part of me is like, cool, really, really cool. You get the main idea. But here, like for example, how many more m's do I definitely need?
1.
1 more m. There's no question about that. Why do I not need 4/8? Because 8 is already how many whats?
3.
3 twos. So how many more twos do I need?
2.
Why 2 more? Because it's a fifth root. It needs 5 things. Please let this make... No, what the fuck. All right, now watch. Watch. Stay with me. What's the fifth root of 2 to the 5th? Is that easy to do? What's the fifth root of 2 to the 5th? 2. Is everybody cool with that?
Yeah.
What's the fifth root of 2 to the 4th? Can you do that as easy? Oh, shit. Why? Because Jeff took 1, 2 away. Well, here, look at what Jeff did now. He gave you a problem where there's 2 freaking 2's missing. Shit. So what do you multiply by then to get back to a place where you could do it easy? How many more 2's does this guy need? 2 more. That's it. Because what's the root say? It needs 5 things. What do I have? 3 things. Give it 2 more. Okay. What makes it legal? Give the top the same shit. So I want to give the bottom, like we said, 1 more m, right? It only needs 1 more m, because it's already got 4. And how many more 2's do we say? 2 more 2's. So then I could do the fifth root of everything. I like it. Don't make too much out of this. It's almost too easy to believe that it is that easy. You're like, there's got to be more to it. Let me make it more complicated so I feel like it belongs in math. Stop that. What's the top? This is a y, by the way. Poor little y. What's the top become? The top just becomes 4my. Oh my. And the bottom becomes the fifth root of 2 to the 1, 2, 3, 4, 5. 2 to the 5th, m to the 5th. So what's the bottom become? 2m. And the top just is whatever the shit it has to be to make the bottom nice. So you got a little give and take. If the bottom starts all ugly and I make the bottom look nice, the top's got to look ugly. It's got to go somewhere, right? There's a bulge here. It's got to, oh shit. Okay, it's going to have to be ugly somewhere, right?
And the 5 kills the other 5s?
Yeah.
What?
The
Oh yeah, the fifth root of a fifth power, they kill each other because they're the opposites, yeah.
They did kill 2 demons? Not just...
Oh hell yeah. What's being taken the fifth root of? 2 to the 5th and m to the 5th.
Okay.
So another way to write this, what's the fifth root as a power? What's the fifth root as a power? 1/5. And what do you do with these powers? You multiply them. Right? Doesn't the 5s all cancel?
Yeah.
That's all I'm doing there.
Okay.
This feels like I'm cheating, but I'm not, because this is what inverse functions do. Fifth power, fifth root, opposite functions, they kill each other. Fantastic. That's why we did this shit, to make it that easy. So the hard part really isn't that hard. It's just figuring out how much more shit do I need here so I can make it easy. And why am I allowed to just give it what is missing? Because I do the same thing to the top. It's balance. Cool.
In the first example, on the bottom left,
Over here,
that one, the denominator, the exponent is a what? A 3 or 2?
3. Because I gave it 2 more 3's and there was 1 already.
Oh, okay.
Yeah. So now I have 3 to the 3rd.
Okay, it's times 8.
Yeah.
Cool.
All right. One more, I guess. I mean, it's really can't be anything different than what I've already done. 11th root of ab squared over the 11th root of 128 a7. No, sorry. Let me get it. m7 w 10. What did we do over here with the 8? Broke it up to see what I really have, right? So what I'm going to do with the 128? Break it up. All right, take a minute to do that. Break the 128 all the way down. See what it's made of. People that know anything about computers, that should be a very familiar number. All right, 32 times 2. Get out of there. 16 times 2. 8 times 2. 2 times 2 times 2. So how many 2's do I have? 1, 2, 3, 4, 5, 6, 7.
There we go.
You guys see that? It's just breaking it down. Divided by 2 because it's even. Then you get an even number. Oh, divided by 2 because it's even. Then you get an even number. Oh, divided by 2 because it's even. So how many more 2's do I need? 4 more 2's because I have 7. And what's the root say I need? 11. So I'm going to start to collect what I need. So 11th root, I need 4 more 2's. How many more m's do I need?
4.
Also 4 more. There's 7 m's currently. How many more do I need to make him happy? 4 more. How many more w's do I need?
1.
Just 1. So I already got 10 w's. It's just 1 more w to make the root happy. What am I going to multiply the top by? Same thing, to make it legal. I put more shit down there, and I put a big number down there. Did the idea change? No. You break the big number down. How many things do you have? How many more do you need based on what this guy needs? So that's why I call it complete the root. The name makes a little more sense. The root's not complete here because there's not enough shit inside. I'm going to complete it by giving it what it's missing of each of the things. So what do you get on the top? I get, what's 2 to the 4th? 16. AB squared M4W. Just to be in alphabetical order. Let me see if anybody gets this. On the bottom, we're going to get 2MW. I've designed it to get 2MW on the bottom. Because what do I get? I get 11th root of 2, 7 times 2 to the 4th is 2 to the 11. M to the 11. W to the 11. Pop! They all kill each other. And so I get 11th root of 16 AB squared M4W all over 2MW. I have a special place in my heart for the person that goes one more step and reduces the 16 and the 2. What has that person done wrong? 16 divided by 2 is 8, Jeff. What's wrong with that? It's an 11th root. You don't have 16. You have the 11th root of 16. You have the number that is 1/11th of 16. There's no 16. You can't divide these, they don't have the same root. Okay, that's enough of that. All right. So I love this. This next section is sort of a catch-all of. Okay, we've talked about all this other stuff. Now, what about all the other properties in the world? That makes it sound like it's hideous, but just tell me your gut instinct on this problem here. Well, let's not make it too evil, Jeff. Here, put in front of this 5 square root of 7. I like it. 5 square root of 7 times 2 square root of 3 plus 5. Yeah, and the part that really trips people up is kind of funny to me, and you're like, that's a shitty thing to say. How do you do, real quick, don't even write this down. How do you do this problem? What would it be? Well, what would you get here? 10x squared. Now, did it enter your brain? I don't care about the other stuff. Did it enter your brain at all? Like, does that 5 go with that x? Did that come in your brain at all? No, you're like, I can multiply 5 and 2, so I'm going to do that. I can multiply x times x, so I'm going to do that. And then all that shit's together, no worries. And then people freak out here. What can I multiply together? Can't I do multiply 5 and 2? Because they're whole numbers. They have the same root, namely no root. So 5 times 2 is 10. Can I multiply square root of 7 times square root of 3?
Yes.
Yes,
Yes.
because they have the same root. Square root of 21. So of course the 5 and the 2 go together, and the 7 and the 3 go together, just because of what, the same way that the x and the x goes together, and the 5 and the 2 go together, because that's what they can do. They're allowed to do that. What's 10 times x squared? 10x squared. Oh, I can't put that together anymore. And then what are you here?
10, or 25.
Yeah, 25.
7.
Square root of 7. Can I go further?
You could.
35 square root of 28. 35 square root of 28. Please somebody yell at me. Don't even write that shit down. What the shit? How do you get 35 of these when I don't see any square root of 28s anywhere, right? Can I go further? Are these like terms? No. You stop. They are not like terms. I can't simplify either one of them. I'm done. Yes?
Why aren't they like terms?
What do you need to be like terms? You need these to be exactly the same. Right? Can I add 10x and 10x squared? Can I add those together? No, because these are not exactly the same.
But the 7 and 3 aren't the same. But yet you.
I wasn't adding.
Okay.
Can I multiply x and x squared? All freaking day long. So multiplication has much, more relaxed rules about. Addition is like, oh, I can only put things together that are exactly, That's what LCD is, by the way, right? 3/5 plus 2/5 is 5/5. They have the same thing, so I'm allowed to put 3 of these and 2 of these together because they're the same thing. Yes.
So if they had like a GCF and they had like terms, could you reduce them?
You mean in the?
Yeah, if all of them were like, if you could reduce them all like to like 2,
Yeah.
like divide them all by 2.
You mean like in the square root?
All 4 of them, all 4 places.
All
10
4
to-
places.
10 square root of 21, 25 square root of 7, if they were all duplicable by 2s, could you do that?
No, I don't know what you mean.
Would there ever be an instance where you could do something?
Of course, definitely. We're about to get there.
Okay.
Yes. Why? How do I know I can't do anything here? These aren't like, and I can't make them like because I can't reduce either one of these. I
if
can't
you
simplify
could,
either one.
If they were like 22 and 6.
That doesn't mean shit. If I had 10 square root of 22 plus 25 square root of 6, are they like terms? No. Is there a part of 6 that I can take the square root of? No.
Okay.
Doesn't change anything. If this was 10 square root of 25 times 25 square root of 18,
Okay.
can I do something? Well, definitely. Square root of 25 is 5. And square root of 18, I can break that up and simplify it, right? That's when you can do more.
Okay.
Yeah. Yes?
Would you want to pull a 5 out of the 10 and 25?
All right. Let me. This is something I have to say a lot about, and don't take it wrong. I'm sorry. A factor is opposite of simplify. What's simplify mean? Do the operations. What's factor mean? Undo multiplication. Completely different things. So factoring is the opposite of simplifying.
And right here we're simplifying.
Right here we're simplifying. We're doing what the operations want me to do. If this said factor, you'd be like, I'm done. All right, yay. It's already factored, right? I wouldn't do shit. If this says simplify, yeah, I don't want to factor. Okay. So, what about the problem I was about to write down like this? 2 square root of 3 minus 5 square root of 6 times 3 square root of 3 plus 2 square root of 11. Not a hard problem. We already know how to do it. So do it. Poor little dude. Forgot his power supply. Oh, let me catch up here. Who came in after I passed stuff out? Anybody not get the stuff back? Let me know later. It doesn't make sense. Great sheet. David. Who else? Who's else? So if you just subtract 2 minus 5, and then just 3 and 16. Count that together. All right, let me catch up to you. Of course, what am I doing? I'm just boiling this out, right? So here you get what?
6.
6 square root of
I don't know.
Negative, or
I
9.
don't know.
what? What happened? What?
Is it
Nine,
squared
square
or
root
is it
of
9?
6 square root of
Square root
9.
of 3 times the square root of 3 can't be 9. Is that what you're
Well, I
asking?
mean, square root of 9 in the inside.
Yes. Yes, it is square root of nothing, right? Now, I would love it if a lot of you guys get this shortcut. Isn't square root of 3 like half of 3? In fact, it totally is, right? Isn't it 3 to the 1/2? So it's half of 3.
Yes, I do.
So what's half of 3 times half of 3? A whole 3.
So you,
Because what is the square root of 9? 3. So if you see square root of 11 times square root of 11, the answer is 11. Now if you don't get that, then you can do square root of 9, and then the next step you can go, oh yeah, it's 3. But some of you guys maybe can go square root of 3 times square root of 3 is 3. Half of 3 and half of 3 makes a whole 3. Whole 3. What about here? Yeah, 4 square root of
33.
33. And then what about here?
negative 15.
15 square root of 18. And then here,
Negative 10.
minus 10 square root of
66.
66. Now you simplify what you can. There are some things I can simplify. This is 6 times 3, which is 18. You see how I already know 33 ain't doing shit because 33 is 3 and 11. I don't have enough of anything to do square root. Same thing with 66. 66 is 11 times 6, which is 11 times 2 times 3. I ain't got 2 in anything. I can leave that one alone. But what about 18? Android 18. Let's see. So this one is square root of 9, square root of 2. All right. What square root of 9 is? 3. Square root of 2, I don't know. So finally I get 18 plus 4 square root of 33 minus 45 square root of 2 minus 10 square root of 66. And a lot of you guys are like, your brains are telling you, do more, do more. And you say, brain, shut up, I'm done.
Where'd you get the 18?
6 times square root of 9. What's square root of 9? 3. 6 times 3 is?
Oh,
Can you make this 22?
No.
Hell no, I don't see any 4 up there. I see a 4 at 33, whatever the hell that is. It's not like terms with 18. There's no like terms anywhere. So don't force it to go further just because you feel like you're supposed to be able to go further.
So because 15 and 18 got 3 in common, that's why we did that one?
No. Square root of 18
Uh-huh.
is the square root of 9 times the square root of 2.
Right.
What's the square root of 9? 3. It didn't matter that was 15. That didn't matter at all. That could have been a 7. That could have been a 28. That could have been whatever. Square root of 18 is square root of 9 times square root of 2. I could do the square root of 9. I leave the square root of 2. Same thing we've been doing before. Square root of 18. Square root of 9 times square root of 2, which is 3 times square root of 2. Is that cool? Right? So whatever's in front of this is just going to multiply by the 3 that's there, right?
So is it just because 9 is you can square it?
Of course, yes.
66.
Yes, this is the simplifying radical stuff that we spent a lot of time on yesterday. Yes?
So the gist of it is, if you find the highest multiplicative number for like a square, cubic, try to find in that number, if you can't find it, then.
So here, yeah, here 9 is a square number, it goes into 18. And it's a square root, that's why I'm looking for a square number. I like it. If there's a cube root, I would look for a cube number. 1, 8, 27, 64. That's why it's important to know those numbers. Those are the ones you try. How are we doing so far? Is that? Okay. Did I lose everybody right here? This stuff right here that we did yesterday? Are you guys really here? Or is this, am I still, what did I do last night? Okay. Jeff is just in his living room just talking and nothing. Okay. I mean, it's FOIL, and then simplify any radicals you can, like terms. Yes?
So you couldn't do like the 66 because when you try to do that, the outcome is not.
It's 6 times 11, which is 2 times 3 times 11.
Yeah.
Do you have a 2 of anything? No. Is there any square that goes into 66? No.
Okay.
So that just can't be done. Yeah. Okay. Here, you guys try this one. Let's see. Let's do. Sure, do that again. Minus 3. I like it. 2 square root of 3 plus 5 square root of 6. Those two. About to.